Hello everyone, my name is Zhicheng Zhang from Nankai University, China. Next, I will report my work temporal sentiment localization, listen and look in untrimmed videos. Let's start with an interesting question. I believe that we have all seen the classic movie Wolf of Wall Street by Leonardo. But what did you feel as the movie progressed? Calmly, we will be delighted with the growth of the country boy. We will also be disappointed that he has gone astray and taken a desperate step. We may even lament the uncertainty of the world and feel fixed emotions for his imprisonment. Based on this, we have two key observations. First, a video can naturally convey multiple sentiments to the viewers. Second, the sentiments conveyed may appear at any stage of the video and last for varying amounts of time. Existing video sentiment analysis works focus on single label classification. For a given video, this work first splits the video manually based on the presence or absence of sentiment, and then classifies the sentiment using a recognition model. However, such paradigm raises two limitations. For the one thing, the well-trimmed video is rare in real world, and the process of trimming brings burden for human. For another thing, the developed model can only process the clip which only contains single sentiment. To address these limitations, we propose a novel task, temporal sentiment localization, named TSL. First, TSL aims to simultaneously localize and classify the sentiments in untrimmed videos. Second, TSL can understand multiple emotions expressed in a video as a frame granularity. With TSL, various downstream applications can be realized and meet the needs in our real world. As internet develops, there is statement shows that 500 hours of video were uploaded to YouTube per minute around the world. Analyzes the sentiment in these videos can boost the development for online education, commercial advertising, and so on. For instance, online education platforms could improve the quality of teaching by automatically analyzing users' feedback and his or her attitude. Companies could utilize video data to develop product plans guided by commercial advertising analysis and consumer sentiment analysis. Content providers like YouTube could protect the mental health of teenagers from video containing violent or abnormal content while sentiment-based detection. TSL also introduced new challenges. First, as is well known, training an effective model highly depends on a large-scale, precisely labeled video dataset. But dense full supervision is labor-intensive for acquiring and weak supervision is incomplete for direct training. Second, sentiment owns the nature of abstract ambiguity and perception subjectivity to be solved for obtaining effective model. To address the lack of data and to facilitate further studies, we construct TSL 300 dataset. We first collect videos from multiple sources, including speech video, movie, and TV show. For data annotation, we provide dense full supervision and weak supervision as shown in the left figure. Full supervision provides a sentiment label of each frame in the video, where single frame weak supervision only provides the sentiment label of one frame, which conveys strong sentiment for each segment. We also verify the quality of our annotation by conducting multiple annotator aggregation and testing consistency. Finally, our TSL 300 dataset contains 300 videos for a total of 1,291 minutes. Well, 1,642 sentiment segments are precisely annotated. In Figure 1, we show the statistics of our dataset, which includes the proportion of collected scene, the temporal position and number of segments and single frame annotations. The subfigure A shows that the involved scenes of collected videos vary from the office to the museums, and the types of scenes range from indoor to outdoor. We also notice that a video commonly contains multiple segments from subfigure B. In figure 2, we found that the length of sentiment segment is longer than actions. Intuitively, this is because a high-level abstract, a sentiment segment usually contains multiple actions. To address the challenges, we propose a weekly supervised framework, TSL net, only using single frame supervision for training. Our proposed network extracts sentiment-specific features from the visual and audio modalities to predict the sentiment classification results and distribution frame by frame. First, we extract multimodal features from video and feed them into the multimodal feature fusion module to extract sentiment features. However, due to the abstract nature of sentiment, the fusion of high-dimensional features tend to bring instability in feature representation. Thus, we propose a reverse mapping strategy to preserve the intrinsic part of each modality in multimodal features to prevent unstable fusion results. Specifically, we construct constraints on the mapping between multimodal features and fused features based on contrast loss. Subsequently, sentiment localization module yields the results and distribution of sentiment classification by frame prediction, respectively. In order to bring the gap between fully supervised and weakly supervised signals, we generate two training signals using single frame supervision. The video level and frame by frame supervision are used to learn the category distribution and temporal distribution of the sentiment, respectively. The category distribution is constructed based on magnitude, while the temporal distribution is derived from a greedy search algorithm based on the sentiment distribution. During training, video level training is intended to learn the category distribution contained in the video, and we aggregate the predicted distribution frame by frame for learning. Frame by frame training focuses on the distribution of the sentiment conveyed in a video along with the temporal dimension. Specifically, we predict the sentiment of each frame and constructing pseudo labels for unlabeled frames for learning. In the upper table, we show the experimental results for comparison in TSL 300, where our method achieves 33% improvements in 8 metrics. We also notice that the group of single-frame supervision methods get better performance in comparison with the other weakly supervised methods, since single-frame supervision can provide temporal location information of segments. The bottom table demonstrates that the analysis on different effective modalities. We find that utilizing multimodal information can boost the performance of TSL task. In the right tables, we aim to verify the designing of our proposed modules and losses. We found that learning from sentiment distribution can help detect high-level and abstract sentiment. The left figure shows the example of visualization. For samples with speech videos, our method could focus on the duration with speaker's emotion. This is all my presentation. Thanks for your listening.